So our sine functions are going to be in the form of y is equal to a times the sine of b times theta. Or, and if we want to use it in terms of x, it's going to look like y is equal to a times the sine of b times x. So there are some really handy things that we can tell just by looking at the equation of the sine function for when we go to graph it. And those things are based on the a value and the b value. So what's being multiplied by the sine of theta, and then what's being multiplied directly by theta in the sine function. So b and a are going to tell us some handy things about the sine function. So the absolute value of a is the amplitude of the sine curve. So whatever a is tells you exactly what the amplitude is. So if you go back and you look at our notes from the past 2 days, so graphing sine functions part 1 and part 2, and you look at y is equal to the sine of x, what number is technically being multiplied by the sine of x out in front here? Isn't there technically a 1? Well, if you look at the graph of y equals the sine of x, what's the amplitude of that function? And all those graphs we made. Wasn't the amplitude 1? Yeah, so whatever the absolute value of that number is the amplitude of our function, or the sine curve. So then b, the value of b, whatever's being multiplied directly to theta within the sine function, what you're taking the sine of, b is the number of cycles that occur between 0 and 2 pi. So the number of cycles that occur between 0 and 2 pi. And we'll talk more about what that means in just a little bit. And then 2 pi over b is what we can use to find the period of the function. And remember, the period of the function is just that horizontal distance of a single cycle. So 2 pi over b tells us what the actual period of the function is. B is the number of cycles that occur between 0 and 2 pi, and then the absolute value of a is the amplitude of the sine curve. So let's apply this information to some equations. Well, in example 1, we're given some key information about the sine function, and then we're going to use that information to write the equation of the sine function and graph the sine curve. So, and we only have to graph one cycle. So we don't have to graph multiple cycles, we only have to graph one cycle. So the first one tells us that a sine curve has an amplitude of 2 and a period of 4 pi. So the period tells me the horizontal distance of one cycle. So that means that from 0 to 4 pi is the entire cycle. Okay? One cycle occurs between 0 and 4 pi. Well, if one cycle occurs between 0 and 4 pi, that means that this function is going to have a midpoint of 2 pi. So when we graph these functions, we're going to look for a 0, a maximum, another 0, the minimum, and another 0. So 0 to 2 pi, 0 is a 0, an x-intercept. 2 pi is another 0, or x-intercept, and then 4 pi is another 0, or x-intercept. Okay? So that means that between 0 and 2 pi, we have a maximum, and then between 2 pi and 4 pi, we have a minimum. Well, the maximum between 0 and 2 pi has to happen exactly halfway in between 0 and 2 pi. Well, what's halfway in between 0 and 2 pi? Pi. Then if we know the amplitude is 2, that maximum occurs at pi 2. And then the minimum then between 2 pi and 4 pi happens between halfway between 2 pi and 4 pi, which would be at 3 pi, and then it has an amplitude of 2, so it's going to happen at -2. And then sketch in your curve. Here's our maximum, here's our minimum. So how did I know to look for those things? Well, if you go back to the graph of the sine of pi, of the sine, y equals the sine of x, and you look at your notes from the past 2 days, so this is 0, this is 2 pi, this is pi, this is 1, and this is -1. So there was a 0 at 0, at pi, and at 2 pi, right? Then the minimum of this graph, sorry, the maximum of this graph happened halfway between 0 and pi, and it happened at 1. Well, halfway between 0 and pi is pi over 2. And there's your max. Then halfway between pi and 2 pi is 3 pi over 2. And then we had our minimum happen at -1. Here's your minimum. So your sine curve has a 0, a max, a 0, a minimum, and then a 0. 0 max, 0 min, 0. So whenever we graph these other variations of that same sine curve, remember this is your parent function, you're always going to have a 0, a max, a 0, a min, and a 0. Now if it's reflected, you're going to have a 0, min, 0, max, 0. So there we go. Now we need to write the equation of this graph, of this sine curve. Well, the equation needs to be in the form of y is equal to a times the sine of bx, or b times theta. Well, remember, a is the amplitude. What's the amplitude of this sine curve? The amplitude is 2, so I'm going to plug in 2 for a. The sine of b times x. Well, b, let's remind ourselves what b is. B is the number of cycles that occur between 0 and 2 pi. And we can find 2 pi divided by b gives us the period of the function. So if we need to, we can use the period to help us find b. So remember, the period is equal to, what did that say? 2 pi over b. So the period is equal to 2 pi over b. Well, we know the period of this function is 4 pi. So 4 pi is equal to 2 pi over b. We can use this information to actually solve for b. So multiply both sides by b, and we get 4 pi b is equal to 2 pi. Divide both sides by 4 pi, divide by 4 pi. B is equal to pi divided by pi cancels, and 2 over 4 reduces to 1/2. So that means that we're going to plug in 1/2 for b. So y is equal to 2 times the sine of 1/2 x, or y is equal to 2 times the sine of x over 2. Those mean the same thing, and I'll accept either as your final answer. So let's see if that's right. Does 1/2, that means half of the period, or sorry, half of the period, or half of the cycle occurs between 0 and 2 pi. So between 0 and 2 pi, how much of the sine curve actually occurs? Only half of it, because the other half is between 2 pi and 4 pi. So that's why b is 1/2. because only half of the cycle occurs between 0 and 2 pi. And remember, b represents the number of cycles that occur between 0 and 2 pi. So if only half of the cycle occurs, then b is a half. All right, so using that information, why don't you go ahead and give example 2 a try. You're doing the same thing. You're given the amplitude of the sine curve, the period of the sine curve, and you need to graph it. Look for your 0, max, 0, min, 0 again, and then write the equation of the sine curve as well. So press pause and then press play when you're ready to check your work. So the sine curve has an amplitude of 3 and a period of 2 pi. That means from 0 to 2 pi, we have one cycle occurring. So 0 to 2 pi, that's my period. That means that I have my other 0 happening halfway between those 2 points. Halfway between 0 and 2 pi is pi. Then I have an amplitude of 3, and that maximum's occurring at 3, and then halfway between 0 and pi is pi over 2, or half pi, and 3 would be here. Then my minimum occurs halfway between these two zeros, so halfway between pi and 2 pi is 3 pi over 2, which is, then my minimum is going to happen at 3 pi over 2 and negative 3, which is right here. So then my sine curve looks like this. Okay. So we know that the amplitude is 3. So when I write my equation, y is equal to 3 times the sine of something times x. So what has to go here? Well, we need to find our b value. So remember, b represents the, what does it represent? The number of cycles that occur between 0 and 2 pi. So how many cycles occur between 0 and 2 pi? Well, it looks like exactly one cycle occurs between 0 and 2 pi. So shouldn't b be 1? Well, 1 times x is just x, so we're going to write that like a mathematician. Well, let's make sure that we're right. So the period of this function was 2 pi, and that should be equal to 2 pi over b. And we just want to make sure that b really is equal to 1, that we are correct. So we're just checking that algebraically. We're going to multiply both sides by b. So b times 2 pi is equal to 2 pi. Divide both sides by 2 pi. And we get b is equal to 1. Sure enough, b is 1. And that's it for today.